Hello everyone. So today in this recitation video, we will be looking at plots in R. So before we get to plots, there is some background work you need to be familiar with. So the first thing you guys need to be familiar with is changing your working directory. So the specific commands you want to revise are getwd and setwd, and that should be able to allow you to set your directory. And after that, you would also want to look at how to load a CSV file into a data frame. So you would want to look at the read.csv function, and that would load your CSV file into a data frame. If you're not clear with your basics, I just recommend going through the first few web pages on this tutorial. I'm uploading this PPT file into the same recitations folder, recitations 2 folder on Sakai, so you can go through that. So moving on, the topics that we'll look at today are scatterplot, bar plot, box plot, histogram, and mosaic plot. And for all these plots, we'll also be looking at changing their captions, colors, titles, and I also tried to provide some additional resources for them as well. You can just click on the links and you can just go through them and check out how to be more creative with your plots. So the first thing we'll go through is scatterplot. A scatter plot is the most basic kind of plot. So whenever you think of plotting something, all you want to do is put some points on a graph saying, this is the x coordinate and that is the y coordinate. So that's exactly what a scatter plot does. You supply it a set of x coordinates and a set of y coordinates, and all it does is it puts them on a Cartesian plane. A Cartesian plane is just an XY plane. So the parameters for scatter plot is as follows. So you need to use the plot function to build a scatter plot, and you need to supply the following parameters. So first you need to supply x, which is a set of x coordinates, and then y, which is the set of y coordinates. And after this, you need to supply some common parameters, which is main, which indicates the title of the graph, xlab, which indicates the title of the x label, and ylab, which is the y-axis label. And then xlim and ylim are the limits of the x and y axes used for plotting. So let's try out an example for this. So what we're doing is we are just giving a set of integers from 1 to 6 as the x coordinates and a set of integers from 2 to 7 as the y coordinates. And we just want to plot this on a xy plane. And what we expect out of this is some points like 1, 2, 2, 3, and so on, because x-axis has 1 to 6 and y-axis has 2 to 7. So let's just run this. I think I ran it already. Okay, so what we're going to see is uh, we indicate that the title of the plot is over here in the main parameter, and the x label is in the x lab, and y label is in the y lab. As for the points, you can look at the points, and the x coordinates of the points are 1, 2, 3, 4, 5, and 6. And the y-axis points are 2, 3, 4, 5, 6, 7, just like we supplied. So this is scatterplot, and you use scatterplots whenever you have two sets of numerical data and you just want to plot them on a Cartesian plane. I have included a link over here. You can just go through that and you can find some additional resources like creating multiple scatter plots in the same graph over here in this link. So the next plot that we'll be looking at is the bar plot. So a bar plot is used to plot rectangular bars, which are proportional to the variables in the vector. So while building a bar plot, you can also give different colors to each bar, and we're going to discuss the basic syntax for that. So over here, the first parameter, h, is the vector that contains the numeric values used in a bar chart. And after that, xlab, ylab, and main are the common parameters that we discussed before. But there's a new parameter now called names.arg. This names.arg parameter basically contains the names you give to each bar in your bar plot. And then we have something called col, which includes the colors that you want to give to each bar in your bar plot. Let's look at an example for bar plot as well. So first we want to plot 5 bars with the following lengths. So the first one has 10, second bar has length 20, third one has 40, and so on. And after that, we give 5 names to the above bars and 5 colors for corresponding to the above bars as well. Yes, so when we run this example, we can find that we find a bar chart that contains rectangular bars that are proportional to the values supplied in the array that we gave. So over here, we can find that the bar plot contains 5 different colors and 5 different X labels, exactly in the order that we supplied above. So this is basically bar chart, and over here, you need to remember that you can supply X and Y limits as well. I did not do that because right now we don't find an issue with the X and Y limits, but you can definitely do that as well. So some additional notes on bar plots. So bar plots usually need only one numerical vector as input. It plots each value of the numerical vector as a rectangle on the graph. This rectangle is proportional to the value of the variable. And if you want to find additional resources about this, you can check out this link. Moving on, the next thing we'll be looking at is the box plot. So box plot shows the distribution of data in a data set. You can see plenty of things in a box plot. So what you can see is the minimum value, maximum value, median, first quartile, third quartile, and the outliers. So now we can look at the basic syntax to create a box plot. So the most important thing you need to create a box plot is supplying X. And an X can be both a vector or a formula. And after you supply X, you also need to supply data, which is the data frame that X belongs to. So once you supply both of these, you can just run the boxplot function, and we'll look at an example for both a vector and a formula now. So first, looking at an example for just a vector. So what we have is X, which is a vector of integers from 1 to 10. And for X, we just have one box plot, and we just want it in a color red. So running this piece of code, we can get a box plot of color red. Over here, you can observe that the lower line represents the minimum, which is 1. And this represents the first quartile, which is 3. And this represents the third quartile, which is 8. And this represents the maximum, which is 10. The bold line in between is the median, which over here is 5.5. This is a box plot using just a vector. But apart from this, you can also do one more thing, which is using a formula. You received a data set in your assignment 2, which is Moody data set. Over there, if you have gone through the data set, you should be knowing that there is something called score and a letter grade. If you want to find out what letter grade corresponds to which score distribution, you can put in a box plot and do the following. What you can do is write down the box plot function and then write down a formula as follows. So on the left side of this operator, this is called tilde. On the left side of this operator, you put in whatever goes on the y-axis. And on the right side of this operator, you put in whatever goes on the x-axis, which is grade. So this should match the exact column name that your data frame contains. So once you read that CSV file, you just supply the exact same data frame into the data parameter. And you can also give it title and labels for the axes. And over here, I just use the same colors we used above. So now running this box plot using this formula, what we can find is the score by letter grade. So over here, we can find that whoever received a letter grade of A had a minimum score of roughly about 75 and a maximum score of roughly around 98, 99, and so on. So over here is the same thing, but in this graph, we find something new, which is these circles. So these circles represent the outliers. So these circles indicate that they were not used in the computation of the quartiles and the median. They're just not fitting the distribution, so they were indicated as circles as the outliers in the distribution. So now let's look at some additional nodes for box plot. So whenever you want to create a box plot, you need to use the tilde operator. And whatever goes on the left side of this operator is on the y-axis, and whatever goes on the right side is on the x-axis. You need to remember that while plotting a box plot, like multiple box plots on the same graph, you usually need one of these to be categorical and one of these to be numerical. However, when you're just using a vector, you just need the one vector to be numerical. So this is about boxplot, and you can find additional resources on this link. Moving on, we look at histogram. A histogram is very similar to bar plot. What they do is they both create rectangles that are proportional to the values. However, a bar plot directly plots the values of the vectors, but histogram splits these values into a continuous range. And then it plots the number of values present in each particular range. So let's just look at an example. Over here, we have, once again, the Moody data that was supplied in assignment 2. And we want to plot a histogram of all the scores of the students. So first we read the data set and we assign a bunch of random colors for the histogram. And as the first parameter, what we need to supply is a vector containing the numerical values used in the histogram. And then after that, one more important parameter that you need to remember over here is the breaks parameter. This one specifies the width of each bar that the histogram uses to split the ranges. Let's just run this piece of code and we will understand the output. So over here, now we know that from 0 to 10, around 75 to 80 people received a score between 0 to 10. The highest frequency of students were present in the 40 to 50 range. So you can basically get an idea about a distribution of a numerical value using a histogram. So some additional notes on histogram. You can specify the width of each bar using the breaks parameter, as I mentioned, and you can change this up in case you want a different breaks. Let's just run this again so that you get a clearer picture. And so now you can find that it's split into 20 different ranges instead of 10. So the next plot that we're going to be looking at is the mosaic plot. A mosaic plot is very useful to visualize data from a two-way frequency table. For example, in the same Moody data from your assignment, if you want to plot the number of individuals per letter grade who are on a smartphone, you would probably want to look at the mosaic plot. I know it's pretty confusing, but once we look at an example, it will get pretty clear. So the lengths of rectangles in the mosaic plot represents the frequency of that particular value. I'm going to explain this using an example, but first let's just look at the basic syntax. The first parameter in a mosaic plot is the formula. And that is the most important parameter because that dictates what goes onto the mosaic plot. In the formula, we have first a grade, and then we use the tilde operator to once again signify a formula. And then we also have the on smartphone. Let's just plot this graph to see what the output is. So now we can see that there's a variety of different colors and a variety of different sized rectangles. Let's try and make sense out of this. So over here on the x-axis, we have the grade, and on the y-axis, we have on smartphone. First, let's look at the grade A. What we can make out of this is that among the people who got grade A, the people who used their smartphone most frequently are the highest in number. And just clearing it up once again. Among the people who got grade C, the people who never used their smartphone are the highest in number. So you can basically get information about a two-way frequency table just like this using a mosaic plot. So now we're done with the mosaic plot. Let's just look at some additional notes. So the width and length of the mosaic plot, as I explained, can be used to identify the frequencies of the elements present in that particular rectangle. So over here, the green rectangle over here represents the frequency of people that received a letter grade of C and who never used their smartphone. In the end, I also included some references and some additional notes. First, we have a link on the Data 101 portal that contains all the plots and their descriptions, and you can just go through them and get thorough with your basics. And after that, we also have a good art tutorial on this link. I really like this because they explain everything right from the basic syntax to high level plots. And this is some additional documentation about the mosaic plot. If you want to know more about it, you can just visit that link and learn more. That's it for today. Thank you for watching the video and see you guys next time.